Hey, it's Miss Wesley again, and I have a little challenge for you. Now that we've been playing around with polar graphs for the past couple of days on the calculator and graphing by hand, I want to see if we can bring some of our imagination to life in these graphs and figure out how sometimes we see a real life object within them. And I want to give you a few examples of me just literally messing around with numbers and polar equations. I'll go to my graphing calculator first, and I'll hit mode to make sure that I'm in polar mode first. And in my case, I was actually working in degrees for a second. So I switched my calculator to degree mode. Well, that would mean I would have to switch my window accordingly. So I went to window just for a nice whole revolution around the unit circle. So 0 to 360 for the thetas. A theta step that's okay for a standard theta step, smaller if you want it to be smoother, of 7.5 degrees for starters. And I set the x max and min at -4 and the y max and min also at -4. So I went into my equations and I typed this one in. Seems so tame. 3 cosine of 4 theta. Are you familiar enough that you could predict that this is going to be a rose and the rose is going to have what? 4 times 2, 8 petals. So I hit graph just to see what I see, and I see that it's an 8-petaled rose. Okay, it's a little bit jagged. I can make the theta step smaller if I wanted to, but I'm actually going to go the other way. So one thing I want to do just for fun is turn the axes off so that they're not bogging me down in my picture. So I'll hit second and zoom for format, and I'll just go to axes, and I think yours might just say on or off. I can cycle through a bunch of different cool colors, and then I think one of them, actually white might do the trick, right? Because that'll make the axes hopefully not appear. And then I'll hit graph, and I just get the flower. Does it look a little too squash for you? Not as symmetric as you'd like it to be? Well, we can handle that with a zoom 5. I'll try zoom square. Okay, I'm back where I started. Now the fun begins. I want to go to window, and instead of making the theta step smaller, I want to make the theta step bigger. I want to make the theta step every, how about 15 degrees? So let's keep the theta step at 15 degrees, and let's just see what that does to the graph. Remember, this is the calculator taking points at a lot fewer spots around the unit circle, so it has less to connect. It's filling in the pieces the best it knows how. So you get what? Would you call it like a cool snowflake looking thing? Not bad. We could put other equations on top of this to spice it up and make it look even cooler, but you'll never guess what I stumbled upon. Okay, so I went to window, and I decided what would happen if I took the theta max up really high. So for my skater boys out there, what would be 3 360s, right? 3 times around the unit circle. I'm just going to go all the way up to a 1080. Call me crazy. And everything else I'm going to keep the same, and I don't see much of a difference on the graph. I get that same snowflake shape. And then I don't know if my finger slipped or what, but I did something crazy. I went to mode, and then I changed it back to radian mode instead of degrees. I want you to buckle your seatbelt, hold on for a second, and see if when I hit graph now, you see like a famous George Lucas movie character. I just saw it in this graph. Who would have thought? And I got a polar Darth Vader right before my eyes. And why did it do? There is a reason it did what it did, right? You're talking radians now instead of degrees. So you going that many radians is a whole different story, right? For each time that it's going to take points around the unit circle. I thought that was kind of cool for starters. A lot of you guys, as you mess around with these graphs, you're going to want to go to Desmos, and that's what I did here. And the other day, there was no rhyme or reason to the things I was typing in. I was just picking random numbers to see what I could see, to see how cool I could make it look. I'm going to hit the wrench up in the top right corner of Desmos and change the grid to a polar grid, and I'll make it r equals, I'll give this a try. This is what I just chanced upon. R equals 5, I said tangent of 6 theta. And I just typed in a theta for that. So that looks kind of cool. And I raised 6 theta just for the fun of it. The theta part I raised to the half, so the square root of theta instead. And I don't know, I got like a cool design. Sometimes it won't look so recognizable at first. It'll just look pretty geometric. Let me move myself out of the way. But I could mess around with the zoom of this, and it's easy to zoom in and out with Desmos, and you see more and more swirls, and it just starts looking different at each step. I just thought it was a cool little tangle of graphs. And this is all from just like one equation. So that, I started to like the way that looked. All right, let's see my other ones. Then I was like, let me go with more trig functions. So I typed in the number 3, r equals 3. And instead of just taking the sine or the cosine or the tangent, I did all 3. So I typed in the sine of the cosine. Well, that looked kind of cool. Of the tangent of, wait for it, theta. And that's what I got. I thought it was so cute and it looked like sort of a bumblebee of sorts. I guess you could make it into that, or maybe there's something else that you see inside of it. So maybe one of these polar graphs will look more like an insect too, and you can mess around with the theta step on Desmos also. What if I wanted this to be a bumblebee and it was caught in a spider web? I could put another equation here and make it r equals zero point 0.1 theta. Remember that's going to give you a spiral of Archimedes, right? It's a spider web, a spiral that's around whatever I call that shape originally. Okay, let me clear these and I'll give you one more. I tried this one. So r equals parentheses the sine of theta minus the cosine of theta plus the tangent of theta because I wanted to incorporate all three of those. So that looks a little weird already. And then times 3 theta. Put that outside of it. And I was playing with not just the zoom on this, I was playing with, oh, I thought that looks so cool. I don't know what you would call this, but as you zoom out, it's like, I don't know, frets of a guitar or something. And I was playing with the theta max. I just thought, what would it look like if I took it above 12 pi, like took it to 20 pi? And you get, it just kind of widens and you see more of it. I mean, the sky's the limit with Desmos. I could do 100 pi, and then it just looks so cool as you zoom around it too. So feel free to mess, look how 3D that looks as well. Feel free to play around with polar graphing on Desmos and or your calculator, and you're gonna see that I've posted a description of a little project you're gonna try for me too. Everything is outlined on this sheet, and if you have any questions, you can just let me know. Because unfortunately we're not together for you to give me your artwork in person, I guess I'll wait and I'll hold out hope that maybe you can give it to me the next time I do see you in person. I want you to submit your work in one of two ways. So you can read through this. One way you could do it is you could graph it on your calculator or Desmos, and you could just take a picture of the screen. So take a good photo where I can see the entire graph on the screen of your calculator, or Desmos has a way I can just export this graph to anybody that I wanted to. I can share the graph with somebody, or really if you want to just screenshot it for me and then email it to me at the address that I put on this sheet, that would be fine too. If the spirit moves you to be a little bit more creative and make this more your own, bring it to life once you think of your object that you want to graph, you could actually trace or sketch or enlarge your graph onto real paper or poster board, and then use markers, use glitter, use whatever you want to do to spice it up and bring your object to life. You're going to be submitting an image of your object to me by email, along with a list of things that are outlined on these project requirements. I want to know what equations you used. I want to know what your window was, what your mode was, etc. So that if I had to check the accuracy of your equations, I could either use my own Desmos or type right into my calculator and see what you could do. I cannot wait to see what you guys come up with. Everything is spelled out on this sheet, and any other questions you have, I would love for you to let me know. Okay, have a great day. I'll talk to you soon.